Chapter 9, Section 9.2, we have intersection and union. We are using these two terms when you are combining some inequalities. For intersection, this is a symbol we use, and this is a U for union. We also say A and B. The word and is a sign for intersection, and or is also for union. Now, let's say in one basket, I have some marbles in one basket, and I've labeled those markers 1, 4, 5, 3. And on the second basket, I also have some marbles, and I label those like 2, 5, 7. Now, these two baskets, what number do they have in common? They both have 5 in common. So if I say this is basket A and this is basket B, A intersection of B, or A and B, is just one number, which is 5. What number do they both share? That is the intersection. So if you have these two here, then they both share this 5. So one is 2, 5, 7. The other one is 1, 4, 5, 3. So they both share this 5 here. Now, union is you include all the numbers inclusive. So union would be 1, 2, 3, 4, 5, 7. It's just with the union, you have all the numbers with no repetition. See, I don't repeat 5 more than once. That's what the union is. So you collect all the numbers with no repetition of any number or any items. So now, like here on some of the homeworks, define the intersections. These two groups are given. They ask us to find the intersections. What is intersection of these two? The intersection of these two are these two numbers, 4 and 8. So the answer for this is intersection is 4 and 8. What is the union? The union is you collect all these numbers with no repetitions. You don't repeat any number. So that's what the union is. Like here, you have like in one set, let's say this is set A and this is set B. What is intersection? What letters do they have in common? They both have B, X, and T. So this is the intersections. So you have intersections and a union. And on this one, graph and write interval notation. This symbol means X is bounded between these two numbers. X is between these two numbers, between 10 and 3. So if you notice out of these 4, the only one that X is between 3 and 10 is this one. X is between 3 and 10. And since we don't have equality sign, then it's a parenthesis. If I put an equality sign here between 10 and 3, if I put the equality sign here or there or both, then you need to have bracket here. So the C is the correct answer. X is less than -3 or X is greater than 1. Normally, union are 2 pieces instead of 1 piece. Like here, X is less than -3. This is -3. X is less than -3 and is greater than 1. See, if this is 1 and this is -3, this is union because we have the word or, and union normally the answer is two pieces, x greater than 1 all the way to positive infinity and less than -3 all the way to negative infinity. This is intersections. X is less than 2 and x is greater than -8. So like you could imagine that here, x less than 2 means all the numbers less than 2 all the way to minus infinity, like 2, 1, 0, -1, -2. And what is x greater than -8? If this is -8, x greater than that. All the numbers greater than -8 is -7, -6, -5, -3, -2, all the way here. So when you intersect means you overlap these two to see what piece do they both, or what number do they both share? Do they both share number between -8 and 2? See, this is the area that both share. The segment that is common between these two. X less than 2, all the numbers less than 2, this is all numbers greater than n. So like this one has 1, this one has 1 too. It has 0, -1, this one has 0 and -1. Okay, so this piece of information is common between these two inequalities or between these two sections. So then we said the answer is this one, C, between -8 and 2. I'm sorry, this one, D, between -8 and 2. All the answers are between these two. Again, this is the union. So for this one, x is greater than 6 or equal to 6. So it's like and then minus x is greater than 3. Look, minus x greater than equal to 3. Since we always look for x, we have to multiply both sides by negative. But when you multiply by negative, you want to change the inequality sign. So it would be x less than -3. See, I multiply this by -1 is x. I multiply 3 by -1 is -3. But we need to change the sign. So the sign will change from greater to less. So for that, let's say if this is -3, x is less than that. So union is you have 6 to infinity and -3. So if you're looking for all the numbers greater than 6 is here, numbers less than -3 to infinity is union, is you have both sections. So in that case, minus infinity to -3 and 6 to infinity. So it would be this one. From 6 to infinity minus 3 to when you see equations like this is another way of intersection. We write it also like this as intersections. So instead of saying x plus 4 less than 7 and x plus 4 greater than minus 4, instead of writing like that, we just put x plus 4 between these two numbers. So this is another way of writing intersections. The thing is, when you have problems like that, what you could do is whatever calculation you do to the, when you're like subtracting negative 4, you got to do it to all three of them. So to solve this type of equations, add or subtraction has to be done to all three. So I put negative 4, negative 4, negative 4. So x is between 3 and negative 8. X is always between 3 and negative 8. So in that, A is the correct one. This is interval notation. There are different ways of writing the final answers. You know, if it's not graphing, you could also put the x between these two numbers, or you could show interval notation such as this. And the reason we have x to indicate that our variable is the x. This is another intersections. Two separate inequality, but you have to intersect it. So in that case, you solve each, like in this one. One is less than a t is greater than 1. The other one is t is less than 12. So in one hand, t is less than 12 and is greater than 1. This one has an equal sign or is a bracket. This one doesn't have an equal sign, so it's a parenthesis. So it's parenthesis 1 to 12. So again, when you have an equality sign, you need to have the bracket. And there is no inequality sign, there is a parenthesis. Since it's and is normally and is one piece. This is two inequality, but it's or, means it's union. So first you solve each. And here. So on one hand, one inequality x is less than negative 9. The other one is x greater than minus 12. See, and then remember, the union is you collect all the numbers. So this basket has all the numbers less than negative 9, and this basket has all the number greater than minus 12. So basically, when you combine these two, you have all the numbers, minus infinity to infinity. When you overlap these two, this is not intersection, this is union. So this one has all these numbers, this one has all these numbers. Together, they have all the numbers. That's why the answer is all real numbers between negative infinity and positive because of the union. If the problem was intersection was different, it was just this piece. But this is union. Again, this is another sign of intersections. When it's between these two numbers, intersections. So in that case, you just add 7 to both sides and then divide. See, x is between these two numbers. Is intersection normally intersection normally is just one piece. This is also intersection, but in the beginning, since you're dealing with the fractions, I multiply every fraction and number by negative 4 because I don't have to deal with the fractions. See, I multiply by negative 4, negative 4, negative 4. That helps me to cancel the denominator. And then you subtract 1. See, x finally is between minus 17 and 11. And remember, 11 is greater than negative 17, right? So you put the 11 on the right and negative 17 on the left. And it is the intersection because X is bounded between these two numbers. Again, this is two is OR union. So we need to solve each of them. In this one, since both sides are negative, when you divide by negative, remember, you're going to switch the sign. See, the sign would switch right here. So the first inequality indicate that the letter A is always less than 11.4. The other one is less than 2. Okay? So the union is collecting all the number. This one already has all the number that exists here. So we could just use this one as a final answer. This sections or this inequality tell me all the numbers less than 2.75 or 11.4 to the infinity are in this basket. So we don't really need that basket because this one said all the numbers less than 2, but you already have all these numbers here. Again, union is collections, all the numbers with no repetition. So this one would cover all the numbers that already exist here. So the final answer is negative infinity and 11.4. Number 14, 15, and 16, I have the solution of these three problems on the separate page. It's very similar to the other problems. You could check. There isn't, see, this problem is intersection. It means you have to overlap these two. But you know these two, when you overlap, there's nothing left. This one is X greater than 2. What numbers are greater than 2 is 3, 4, 5, 6. And this one is less than minus 2. It's like, what, minus 3, minus 2. So they don't have any numbers in common. So therefore, there is no intersection. When you overlap these two, you don't get any numbers. Because in intersection, they have to share the same number. This one doesn't have all the number greater than 2. It has all the numbers greater than negative 2. They don't have any number in common. Now, this section 15 and 16, these are the problems that dealing with domain, okay? Now, when you have a fractions like 1 over x plus 3, for any value of x, I always get a number for y. Like, let's say if x is 0, what is the value of y? 1/3. When x is 1, what's the value of y? 1/4. Even if x is negative number, let's say x is negative 2. Is 1. There is only one number that you cannot substitute for the x. And if you substitute, you don't get any value for y. Y is on, what number is that? Negative 3. Why? Because when I substitute negative 3 for x here, that makes the denominator 0. And what is 1 over 0 when I use my calculator? Calculator will give me the error or undefined. Domain means all the x's. So how do I answer the domain? I say all the numbers work except negative 3. Negative 3, you cannot select negative 3 for x. So domain, which is all the x's, is all numbers except negative 3 Or instead of this statement, you could just say domain is x is not equal to -3. See? This is sign of not equal. So if you say x not equal to -3, that means domain is all the numbers except this. Means I can put any numbers from positive infinity to negative infinity. You're allowed to put any number for x. You always come a value except -3. You cannot substitute -3. That's what the domain is. So what is domain of, like, let's say this problem. What is the domain of f of x equal to x minus 5 and x -1? The only number that is exception, or you cannot exclude it, you have to exclude that, is the number that make the denominator 0. See, here I can substitute any number for x and always come up with a value except 1. What happened when I put 1 here? Then you have 1 minus 5, 1 minus 1. The top is -4, but the bottom is 0. Is undefined. So domain is all the numbers except 1. So anytime we ask you to find the domain for the fractions, you need to look at the denominator. You want to know what number would make the denominator 0. And in order to do that, just take the denominator, set it equal to 0, and solve it for x. That tells you what that number is. It tells you the number that must be excluded is 1. Like here, if I take x plus 3 and set it equal to 0, then x is -3. See, that tells me that include all the numbers except -3. That's how to find the domain. That's why for number 15 and number 16, like in this one, to find this fraction for number 15, problem number 15 is gx is 4 over x minus 2. See? The denominator is x minus 2. I take that and set equal to 0, so x cannot be 2. Means take all the numbers except 2. Domain is all the numbers. Domain is all the numbers except 2. Or in these problems, take the denominator, set it equal to 0, solve it. X is 5. That means domain is all the numbers except 5. You cannot put 5 for x. See, if I put 5 for x, and the top is 9, right? But here is 10 minus 10 is 0, is undefined. So domain is all the numbers from -infinity to +infinity, except 5. 5 must be excluded. So you go from -infinity to 5. You put a parenthesis that shows 5 is not included. 5 is not included. That's what parenthesis means. Any number greater than 5 is okay, all the way to infinity. That's what the domain is for a fraction. We also have a domain for radical. For the radical, what you have under the radical must always be greater than or equal to 0. That's what the domain is. For instance, on this problem 19, you have, see here, these are examples. 17, what you have under the radical must be greater than or equal to 0. That means x always has to be 9 and greater. Okay, if you put any number here from 9 or greater, you always come up with a value. You cannot put 8 here. What happens if I put 8 here? If I put 8, which is less than 9, then the value of y is 8 minus 9, which is radical -1. If I use my calculator, radical -1 is undefined. Calculator will give me error. Why? Because you take a number that substitute that make the radical under the radical negative number. You don't want that. 9 is okay. That's why we put a bracket. Because when I put a 9 here, look, it would be radical 9 minus 9, which is radical. If I use my calculator and put radical 0, calculator give me 0. That means you have it. You have a number. You have a value. It's not error. Like here, what you have under the radical has to be greater than or equal to 0. Okay. That means x11 greater than x, or x has to be less than and equal to 11. Means when you want to substitute the number here, make sure the number is 11 or less. Any number 11 and less, from 11 all the way to minus infinity, if you substitute any number from 11 to minus infinity, it works. Like put 10, 9, 8, all of them. When you substitute here under the radical, you have a positive number. You don't want the negative number under the radical. For this one, what you have under the radical, always set it greater than equal to 0 and solve that inequality. That's what we do. What you have under the radical, we set it greater than equal to 0 and solve the inequality. And the same thing for number 20. So domain, if you ask you to find the domain for radical, what you have under the radical, take that and set it greater than equal to 0 and solve it for x. That would be your domain.